Okay, so we are on week 4, and we are going to talk about the problem set for this week's assignment. I hope you were able to get through numbers 1, 2, and 3. It only required the use of this command. And you should have been able to figure it. If you weren't able to figure it, make sure you ask questions in class. Now, the binomial distribution, remember we talked about the difference between discrete and continuous distributions. So the binomial distribution is an example of a discrete distribution. That is, it's a limited set of numbers and it has fixed values. What I didn't mention was that when we talk about the normal distribution, this is a continuous distribution. And it's continuous because you have large data sets and they're not categories. That is, they can be any value. So you're not necessarily limited to whole numbers. And usually, if you're doing a problem and it gives you a mean or a standard deviation, that's your tip-off that that you're going to use the normal distribution. Okay, so let's look at problem number 4. A southwestern tourist city has records indicating that an average daily temperature in the summer is 82. Remember, this mu means the mean, which is normally distributed with a standard deviation of 3. Based on these records, the probability of a daily temperature between 79 and 85. So let's start out by drawing our distribution again. And this is our mean, so we have 82. We're interested in the probability of a temperature between 79 and 85. So we're interested in basically finding the area under this part of the curve. So we have to do this twice. The first time through, we're going to use z equals 79 minus 82 over 3. This gives us -1. If we look up -1 in the table, table E.2 in your book, you end up with a probability of 0.1587. Now remember, this 0.1587 is this, whoops, I wonder how I erase. That'll work. The 0.1587 is this part of the curve, 79 and below. So we'll have to come back to that in a second. Let's do this the second time with the 85. Z equals 85 minus 82 over 3, which gives us +1. And the probability associated with this is 0.8413. So the 0.8413 represents this part of the curve. So remember, we're only interested in this part. So we need to figure out, given that we have this and that we have this, how do we get this part? And the way we do that is pretty straightforward. We're going to take 0.8413 and subtract the 0.1587, and that gives us a value of 0.6826, which gives us this part of the curve. So the probability of a daily temperature between 79 and 85 is about 68%. Part B. Oops. The probability that the daily temperature exceeds 90 degrees Fahrenheit. I always like drawing these out just because it helps me visually understand what it's asking for. So again, our mean is 82. 90 is above the mean. We're asked for the probability the daily temperature is going to exceed 90 degrees. So we're interested in this part of our curve. So Z equals 90 minus 82 over 3 which gives us 0.9962. So this 0.9962 represents this part of the curve. So in order to get this green part, we have to take 1 minus 0.9962, which gives us 0.0038. All right, number C. Probability that the temperature is below 76. This should actually be the easiest one of all. We're interested in this part of the curve. So Z equals 76 minus 82 divided by 3, which gives us minus 2. And from the book and the table in the back of the book, that gives us 0.0228. And we don't have to do anything else because that represents this part of the chart. All right, number 5. The time required to complete a project is known to be normally distributed with the mean of 44 and standard deviation of 8. What's the probability that the project is finished in 40 weeks or fewer? So our mean is 44, and we're interested in 40 weeks or fewer. So Z equals 40 minus 44 divided by 8, which gives us minus 0.5. Our table gives us 0.3085, and that's the answer. 30% chance, almost 31% chance, that the project is going to be completed in 40 weeks or fewer. All right, part B. What's the probability the project is finished in 52 weeks or fewer? We're still interested in this part of the chart, so it's going to be pretty straightforward. Z equals 52 minus 44 divided by 8, which gives us 1, which gives us a probability of 0.8413. And that is our answer, because we're looking at this part of the distribution. Okay, the last one is a little bit harder, and I didn't give you any kind of hints for this. I wanted to see if you could figure out. But in this case, we're not given x. Instead, we're given the probability. So in this one, we know that there's a 95% chance that the project will be finished in fewer than how many weeks. So we need to figure out x. So let's pull up our graphic again. And we're going to look at this from a different perspective. I apologize for this being so small. But so far, let me just get rid of this. There's got to be an easier way to do this. Oh, all right, let's try this again. All right, let's try this. Third time's a charm. So up to now, when we've been working with our table, we've started on the outside and gone in. And that was because we had the z-score. In this case, though, we have the probability. So if you have the probability, you start on the inside and you work to the outside. So in this case, we know that our probability that we were given is 95%, or 0.95. So what we're going to do in the table is continue to come down throughout this data until we find 0.95. And that 0.95 happens right about there. You see 0.95 is halfway in between 0.9405 or 0.9495 and 0.9505. So what we do now is find the z-score. So the z-score is at 1.6, and then we come over, and we could do it two ways. We could say it's halfway in between, so it's either 1.645, or most of the time we just round it. So we'll use this value here. So we're going to use a z-score of 1.65. So for example, if we had a probability of 55 55.17%, or 55.5517. We see this right here, and that's associated with a z-score of 0.13. All right, so let's go back to our problem. Our probability is 0.95, which gives us a z-score of 1.65. So 1.65 equals x minus 44 divided by 8. This x is what we need to figure out. So now we solve for x. So let's first get rid of the 8. So that gives us 13.2 equals x minus 44. And I did that by multiplying 8 times both sides. So I took 8 over 1 here times 8 over 1 here. And that gives us 13.2 equals x minus 44. Now I need to add 44 to both sides. And that gives me 57.2 equals x. So here's our table, 44, and we basically just said that an x of 57.2 is greater than 95% of the values. And then the last several problems go back to Poisson. And these are, again, this is an example of a discrete probability distribution. And that was the command in Excel that you used to solve this problem.